approachable, accessible, open, and very aware of what's going on. And they're very open to feedback with their students, so they actually, every time they teach a class, they also learn and bring that knowledge onto the next class that they teach, which I found immensely important and helpful.
Hello, and thanks for joining us today here for this live stream with Jason and myself. Now, today's a little bit a difficult day to do this kind of live stream. You may have heard via our Twitter feeds and other news today that earlier this week, Alan Pollard, the founder of SANS, passed away. Alan personally hired me about 20 years ago to join SANS, and so before we just jump into our Jason and Johannes show here, I just would like to acknowledge the huge contribution that Alan had to the field, and in part things like this live stream webcast and things like this, where we are giving back to the community. That's very much sort of what he always wanted us to do, and what he really very strongly supported. So with that, let me just give it a couple of seconds here of silence, and then we'll start our live stream here. So again, thank you for joining us here. My name is Johannes Ullrich. I am the Dean of Research for the SANS Technology Institute. And with me today is Jason. He'll introduce himself in a second. But what I've been doing basically in the last 20 or so years is look at all the different security threats and how things are changing as part of the Internet Storm Center. And one thing that we sort of saw these last couple of years is that with the move of web applications into the cloud, really the nature of the applications changed. And that's a little bit what we want to talk about here. Part of what we'll be talking about is sort of data and such we'll got from Internet Storms and the current threats. Also part about the class that we are teaching. And with that, let me hand it over to Jason.
Hello, everyone. It's Jason Lam here. As Johannes mentioned, we're both in the security world, heavily into the application area. We both teach a class in this area. It's the SEC 522, which is actually undergoing quite a few changes. We're also modernizing it, and even name changing it, into securing web applications, API, and microservices. In my day job, just a little bit of briefing about myself. I am in the financial world for the last roughly 20 years, ranging from all the technical roles into the CISO role. So yeah, that's my background during the day. When I'm not doing my day job, I write courses and teach for SANS. That's what I do. And hopefully we'll have a very good conversation about things that we have been observing recently about the industry trends. Because hey, a lot of things are changing, and we wanted to use this session to talk a little bit about what Johannes and I have been seeing recently, and at the same time, demonstrate a little bit on some of the course material that we've been researching, and just give a little bit of briefing about what we've been seeing, and just want to share with the community. With that, Johannes, hey, why don't we start with some of the trends that you are seeing first? I have heard that you've been very active at looking at people's password and maybe not just people's password, maybe also machines' password as well. You want to tell us a little bit about that?
Yeah, one thing we're seeing here, and maybe you can show the screen I'm sharing. Yeah, thanks, actually. One of the issues that we are seeing is in order to authenticate these different APIs, these different web services to each other, of course, one way of doing this is API keys, credentials that you're presenting. And what we really are seeing is that attackers are more and more hunting down these API keys. So this is data from our honeypot. Let me just zoom in here a little bit so you can see this a little bit better. Because what you're seeing here is sort of one of those requests. Twilio, we're all familiar with Twilio. Twilio, great service. So I'm not really disclosing here any vulnerability in any service like this. You have to keep those credentials somewhere. And if you actually are reading Twilio's documentation how to do this, they recommend environment variables. Environment variables, not the worst way of doing this. Probably not the best one, and I'll let Jason maybe elaborate a little bit on that later. But the nice thing about environment variables is it pretty much works anywhere. A lot of the better methods, like some kind of credential wallets or whatever you have, they're fairly specific to whatever cloud environment you're using. Environment variables work everywhere, and that's sort of why they're being used. And then, of course, attackers are hunting for the files that define these environment variables. And that's exactly what you're seeing here with Twilio. I think I have a couple more down here. Here's sort of some other file names that attackers are hunting for, like .env. Unix people like myself like to have sort of these credential files now start with dot, because then they're hidden in the operating system. Of course, not hidden from someone who knows the URL or guesses the URL and then just hits it via a browser here, via a tool, and retrieves those credentials. Also note how they're sort of looking for dev, broad, stage, so for different credentials that you may have set up, maybe with different permissions. Sometimes people may be a little bit more liberal in the permissions they're assigning to development credentials. Not that I say you should do that, probably shouldn't do that, but I've seen people do exactly that. So these are some of the issues that we're running into. And then, of course, you do have breaches based on that. Let me just switch over here. So give me a second. I should have probably staged that.
As you're switching on that, maybe one thing that we can mention here as well, right? Sometimes I get into this discussion with the security team, development team, and so on about credentials, right? I once in a while hear people saying that, hey, credentials are bad, right? If they ever see credentials in an application, is a bad thing. Why would you have credential? Well, unfortunately, that's how it works, right? Like applications require credential to run. Think about it. Your web server, your application server, how is it going to access your data? It needs credential to run. And that present a little bit of a challenge, right? Like, hey, present the challenge in that if you have credential, people may steal it. But at the same time, you need the credential to securely authenticate between your application server and database and all the other components. So that is, why you need a little bit of a balanced approach to make sure that you have the credential in a secure location. And Johannes, I think you're ready.
Yeah, so I just pulled it up. News broke yesterday, so I had it yesterday on the podcast. That's why I remember it. And Aruba, you may know them. They make wireless access points. They're now part of HP Enterprise. And like anything is better, fancier in the cloud. So you control your wireless access points by connecting to a cloud system that Aruba is putting up for you. And of course, that system is collecting all kinds of metrics about it. It's not necessarily spying on you, but performance metrics and the like. And Aruba apparently lost track of one of the keys they're using to access that data. Someone found it and then, of course, stole the data. Also states here, I think if they had access for something like 18 days or so. The other problem is that this often does go undetected for a while because the attacker is using valid credentials here to access the data. So it's not that an attacker is necessarily bypassing some kind of authentication controls or anything like this. They're authenticating. They're authenticating as a valid user, just using credentials they're not supposed to have. Then, Jason, I think one thing we saw there also with these credentials was that sort of development stage. And so, of course, the way these applications are often created is fairly quickly. We want to kick these applications out there. And one way how these credentials are often exposed is during your DevOps pipeline. And Jason, do you want to talk a little bit more about that?
Sure thing. Hey, Johannes, yeah, that's a good intro to that topic about the CI/CD pipeline and so on. Hey, everybody, every organization that I know of, that I talk to, they are really, into this DevOps, DevSecOps, cycle. Accelerating the pace of development is a good thing. I am definitely not against it. I'm definitely supportive of it, and integrating security into it, that's awesome. What we're seeing a lot of times these days is that, in which you're seeing big incidents that happens related to this, is that, attackers also know, right? As you need to transform yourself, right? Like DevOps, a big portion of it is about automation. And automation is about, from the moment you write a line of code all the way to pushing it out to the production environment. There are a lot of automation that happens and a lot of different software involved in giving you that experience of automation, acceleration, and so on. The bad guys are really honing into that environment. Towards the end of last year, I mean, one of the banner event that happened was about the SolarWinds. Essentially, the attacker broke into SolarWinds, CI/CD pipeline, and they were able to inject additional code that were not, authorized, that were not good. Well, obviously, needless to say that unauthorized code lead to other organizations down the link being compromised. But the highlight of that is that, if we look at the incident from what we know, the bad guys were very smart, right? They're not altering your source code, because at some point, if you look at the source code, you will see, hey, what is this line of code, right? They're not altering it there. They got right inside the automation just before the code get compiled into binary. They insert their stuff there, right? And they are checking, hey, did anyone notice? If nobody noticed, then yeah, put it in, right? That's what's happening there. So, the whole point here is that as we automate, as we get into this CI/CD pipeline, we need to secure those software components, the configurations of those, and make sure that they're all secure and locked down as well. And together with that, right, like I think a lot of people know about the SolarWinds incident. There's also, I think it happened in January this year, and it unfolded in about April of this year, which is the Code Cove. They have this bash uploader software. Code Cove is a vendor in, they are actually selling software and subscription inside the CI/CD pipeline. They deal with like code coverage and so on. So they're inside your CI/CD pipeline. They got compromised. Their network got compromised. It has something to do with their Docker setup. And as soon as the bad guys got in, and you can just imagine, right? Like they alter some of their code inside that bash uploader. That software in turn get into many different organizations, and the whole life cycle starts. The point here is that, if you haven't been planning about your CI/CD pipeline, now is a good time to take a look at how you're securing that infrastructure, how you're securing the workflow, what validation steps you have. That would keep yourself safe. And a big chunk of it is also, how do you configure it securely, right? Like the configuration is paramount. And I think Johannes and I have been looking at this configuration aspect hugely in recent, I would say, 18 months or so. Like there has been so much configuration. Johannes, do you have any specific things you want to share?
Yeah, I think there are a couple things I just want to add here. So first of all, CI/CD, also what components you're using. I think that Bash script is like a huge example, very including code sort of dynamically from all kinds of external sources. Of course, supply chain is always sort of the keyword here that people go by. That never-ending dumpster fire of malicious NPM modules, I think, is a big example here. And I don't think anybody I've seen has really sort of a good handle on that necessarily. How do you distinguish a malicious from a non-malicious NPM library? On the other hand, if you want to make life easy for developers, and I consider myself a developer, and I kind of don't like that when it comes to application security, developers are usually blamed for everything, but a lot of it is configuration of the application as well. Like, how are we configuring authentication for example, a backend data store? And there are many examples in particular with these sort of more modern NoSQL databases, which do have, in the most cases, authentication, but you have to enable it. You have to go through the motion, and CVS, for example, lost a bunch of records just by basically not doing authentication. And this you could get away with. It was not a good idea, but you could get away with your self-contained on-premise application because you had that perimeter that really protected you. Once you move these applications to the cloud, once you're moving it in particular to sort of cloud-native components, you can't get away with this anymore. It will be found, it will be exposed, and well, we had the big case recently where it was considered a crime to do a view source, but that is probably the least you can do with an application like this. And actually, let me show you a little demo here that someone's doing in class, and see if we can just quickly switch to the shared screen again. Thank you. So this is an application I really like. It's close to home. And I'm not showing any vulnerabilities here, but just how you're basically seeing how the application works, in these more modern distributed applications. So this kind of here, I'm living in Jacksonville, Florida, and the city has this real neat sort of mapping application where you can dive in and basically get information about specific properties here. So you can look up, hey, who owns this particular property here? And but how does it work in the back end? And in a modern browser, I'm not going for a view source here. I'm going straight for the developer tools. So, and then looking at all the requests being sent back, and you kind of see now how the application, how JavaScript within the application is reaching out to different backend APIs. Now here in this case, they do it sort of neat and I think actually not bad, where this request is going to this, and let me zoom in a little bit again so you can see that. To this backend URL here, some kind of proxy or so with this artificial host name. So at least it's not easy for me as an attacker to directly go in there and figure out where the data is coming from and maybe bypass any kind of authentication or access control rules that this front end imposes on me. Let me show you a different version of an application like this. And I'm just showing you the request that was sent by that application. So let me just zoom in here a bit again so people can see it. And so this is just a snippet of XML that you would send back if you clicked on a map like this. And in this case, you have like no obscurity even. Like in the application I just showed you, what actually happened in the backend at least was a little bit obscured from you with these artificial host names and things like that, that you couldn't sort of hit directly without sort of going through the application that essentially sort of implements kind of a proxy here. But you see very basically send a SQL query back. We send a list of field names that we would like to retrieve, and then we send a where clause. And where it gets really interesting is, if you're looking at what this where clause looks like. Last name owner not like confidential. So apparently I'm, as a user, telling the application, please don't tell me anything confidential. And things like this, of course, is trivial to bypass for an attacker now. It is like being able to directly connect to the database itself. You don't really need SQL injection if you're able to send SQL queries back. I don't see it a lot for sort of SQL-like databases. It looks very much SQL-like, but where you're seeing this a lot is where you're exposing backend components like Elasticsearch and things like this, or MongoDB in particular, where they're really built to sort of receive requests from JavaScript. That's of the architecture that you're kind of going for with this here: low friction, low latency, real high speed. For the attacker as well as for the defender and for the good guy. So that's some of these misconfigurations that you run into, where you all of a sudden expose backend components that were not necessarily reachable in the past. If you sort of had your nice little perimeter around it, your hard shell, yes, you had the soft core, but that hard shell protected quite a few attacks. So now you're removing that shell and you're left with the soft core without even the hard shell around it. And I don't know, we do have a little demo application you actually want to play with. And let me just put up our architecture here, and then Jason, you can maybe talk a little bit about that architecture, what we put together here. So give me a second.
Sure. And I'm very curious, if you say, take out that confidential portion, what would happen? Have you tried?
Yeah, I never attempted it. I talked to.
That's what you're telling, right? That's what you're telling.
I don't like to be part of the news. I actually talked to. I reported this, and like I said, the application no longer exists. So that's one way how this was fixed. But the problem here was that again, it's for Jacksonville here, Florida. In Florida, cities are required to make this data public. There are a few exceptions, like I think law enforcement officers, judges, and such, whose data is not public. The problem here is that they had an internal application that they used sort of in their office, and they basically now expose that application to the public. Now, that application, of course, was created with a different threat in mind if you're using internal. I don't say do stuff like this internally, but that's kind of what happens, like that you can get away with that. What they told me is that the database actually used as a backend here to store the data did not contain any confidential data. And that's actually, I think, a valid and good thing to do. So where either the user that you're using to connect back does not have access to that data, or you just don't have the data in the database, and that's, I think, a real nice thing. Data that's not there can't be stolen. So I would still not expose any data where there is no real business need to have that data actually exposed. And that's sort of how they solved the problem here. Like I said, the newer application actually looks. I didn't really dig into it too deep. I don't want to become one of those, people who looks at the source of a web page and comes in the news later. But it looks like they did it in a newer version quite a bit better. But anyway, Jason, tell us a little bit about the.
Before we get to that, I think the illustration that you made earlier definitely reminded me of the latest and greatest. Like sometimes these things run in circle motion, right? Like, we're going back in the same themes of mistakes that were made in the past. So earlier, what you showed probably isn't, in the grand scheme of things, like latest and greatest architecture. What I am seeing a lot of, for example, the GraphQL interface. GraphQL is, sort of new model, right? In being able to, as opposed to REST, right? Like GraphQL essentially allows you to run querying language directly from the browser to one single endpoint or to the web application, and then let you query data right there. And what we're seeing a lot is that there are a lot of mistakes being made, particularly with access control, and thereby exactly as that, right? Like you are able to see all that query run from the browser, and once it reaches the backend, if you're not careful, not doing the right access control, then it leaks a lot of data. So yeah, good thing to show there. And on this on the screen right now, what we're showing is one of the architecture or one of the model that we have been playing around with. Obviously, super simplified level of modern-based architecture, modern-based application. So think about modern-day application. I like to use the analogy of like maps.google.com, like Google Maps. When you go to Google Maps, right, what happens? When you load Google Maps, you download not just maps, you download a whole chunk of JavaScript code. And then subsequent time, right, once you start interacting with Google Maps, then the JavaScript code runs and goes to the your browser to figure out where you are, right, using geolocation, and then determine, okay, so you're sitting here, for example, Johannes' case, you're sitting in Jacksonville, it will say, okay, let me download the maps in Jacksonville. And then at that point, it actually does a bunch of REST API call, the GraphQL call, and so on. So the JavaScript in this architecture are stored at the static file location, right? So that could be, in the real sense, some S3 bucket, Azure blob storage, and things like that, right? So these are static file storage that just let you download your JavaScript. Once it loads, then your browser has a brain, as I would call it, because the JavaScript gives it a lot of superpower, right? Computing power, and is able to do its own thing, right? It becomes an application that runs inside your browser. Then what it would do is that it will then be able to make API calls, right? The API could be a few different flavor, but it generally lands on, some kind of, in modern architecture, API gateways. Well, why do you need API gateways? Well, what you want to do is from an enterprise standpoint, from being able to keep track of logging, from being able to, maintain certain level of security, you want a gateway. And then behind the gateway, what's there? Well, this is where, if you're like the Netflix, the Facebook, the Amazon, then that's a wonderful and colorful world behind the scene in the gateway. Because, a lot of organizations are running the microservices. So that's on the right-hand side, the blue icons over there. That you can think of it like, it could be 2,000 different services over there, right? Like the API gateways just front all those things. And you may question, hey, why do you have so many? Well, because, hey, microservice architecture, you want it to align with very finite and small sections of your business logic into each service. Well, that's the nature of microservice.
Just also from a developer point of view, one nice thing about these microservices, they really behave like functions. So as a developer, I may approach these microservices with the same way that I used to create like a function or a little library in the past. So that's, I think, also what leads to the growth and sometimes a little bit uncontrolled growth of these libraries.
Yeah,
these microservices.
Yeah, I personally like microservice, from a development standpoint, because hey, in the old monolith, there's nothing wrong with it. Number one, right? But in terms of efficiency and promoting, when you have a big organization, I work in a large development organization, yeah, it gets a little crazy, right? Like, so you want, some of the teams to be able to independently update their component. So, who wants to wait till the end of the year to just release one software release, once a year? You want to be able to update it, very frequently and so on. So that allows you to do that when you segregate and break components down into microservice. One component that we also want to talk about is that IAM service. Some people call it the IDP, like identity provider. That's important because that ties in all the services together. You may only have one user on the left, right? When they get through to the API gateway, you want the ability to track the user all the way to, I don't care how many microservices you have. It could be 2,000, but it needs to be the same user, and you should have visibility about what the user is doing. So the IDP is very, very, very crucial to securing applications that are in this model. And this is where some of the protocol like OAuth, which is rather complicated, plays a big role in securing these applications. So that's what the modern based architecture generally looks like. We're just doing a very high level intro here. And Johannes, I think you have some, wicked stuff to show here.
Yeah. Let's actually see if the application works. That's always the developer's problem here.
Yeah. Whoever developed this, my God, right? Let's see if it works first. And we're doing it live,
we're doing it live, of course.
Yeah, live demo.
But
sometimes
we record these things. But today we decided we'll live dangerous, and so here we do have a very simple application. I'm logging in. And of course, the first thing I have to do is I have to remember my username and password. And actually, what you are seeing here is we're using a couple of open source components for these elements that you saw earlier. Let me just go back here quickly. The API gateway we're using here is Kong. Kong, an open source API gateway. And for authentication, we're using, again, open source software called Keycloak. And I just want to point out, we're not showing any vulnerabilities in these applications. These are solid applications. We're only more talking about how you may misconfigure them. So what we're talking about here really applies to if you're doing this like in AWS with their respective API gateways and what's it, Cognito, I think is what they're calling their authentication service. So the same things apply to other pieces of software as well. So here I'm logging in. I'm actually logging in now into Keycloak. So that's what I'm logging into. And a lot of this, of course, then always involves lots of redirects. And you see here like these authentication tokens and such that are being passed forth and back. So, okay, well, let's just, oops, not my password. We have I think it was student. And I'll tell just you the password is training. But anyway, so now I'm logged in. So now I got logged into the application. And now I have this simple window here that I can use to look up basically some ticket numbers. So a very simple, and I get the pop-up here with the update on my service ticket. Let me do the same thing that I did earlier with the map application and invoke the super secret hacker developer mode. Jason, I think there was actually something about turning off view source in Firefox, I think, or wasn't there yesterday I saw something about a change ticket being released? And I think actually in the sort of enterprise deployments of these browsers, you're sometimes able to turn off things like developer mode. But don't take that as security feature. It's of course, you don't want users in your organization waste time attacking your web app. They're supposed to get work done. But anyway, so let's just look up another ticket here. Okay. So here we have this request. Yeah. And then we have this other super secret feature. Yeah. We can copy the request as curl. And if you're not familiar with curl, curl is a command line utility that allows you to basically play browser. So let me just pull this up here.
Yes, you're doing that, and one thing to also mention here is that, I know a lot of you out there, like, using Postman and things like that.
Yeah.
What Johannes just did, you can copy it as curl and fire Postman and import it back into Postman and use that, as a graphical interface as well. That would work really nicely as well. If you're less comfortable with text, that's what I do. Johannes and I, often disagree on that principle. But
I hate GUIs, but they just get in my way, and really you see what's happening. So how is authorization done in this case, or authentication? It's done via this bearer token, and this gobbledygook here that you're seeing is actually a JWT, so a JSON. Not JSON, a JSON web token. Notice how there are dots. Dots are, and the rest is of base64 encoded. We can actually just take this text here and then base64 decode it. So paste base64. Oops, lowercase d. Yeah. And here we sort of get that JSON. We have a SHA-256 for our authentication, for our signature. It's a JWT, or how Jason likes to call them, JWT. I don't really like that, but anyway. And then sort of an ID here. Now, let's stick with Jason's advice here and go GUI on this. There's actually a nice website that can decode that for us. Just need to extract this. Copy it. jwt.io.
And that website is amazing. Basically, it does the JavaScript decoding of the JWT content, and basically tells you what does it actually decode to. And Johannes is about to show it to us. You just copy it. Sorry, you just paste it right there, and then it automatically decoded for us. And then allegedly, right, like everything is done on the client side, nothing is sent on the server. So no token is hurt in this process.
Yeah. And that's kind of one of the nice things with these JWTs, because we do have to authenticate against all of these different backend services. Now, typically, I would have told you, don't store data that authenticates the user on the client. Like if you had the good old user equals admin cookies and things like this. This works because it's digitally signed. It's digitally signed, and then the recipient, whatever web service we authenticate for, is able to verify that signature, and the user is not able to change that token if it's formed correctly. And if you're using a relatively modern library, then that's usually not a big issue. In the past, sort of issues, for example, have been, notice how the user also tells you how to verify the token. So the user presents the token and tells you, hey, the signature was created with this algorithm. As an attacker, I could swap that to a much simpler algorithm, maybe an MD4 or something like this. I think there was even a none option, or Jason, wasn't there like an option not to have any signature, and the receiving library would just accept that? That was sort of one little issue there. But one thing we really want to focus on, let me zoom in here a little bit on this token, is, so there are different ways to use JWT. Sometimes it could just communicate my user ID. There's sort of various ways to log in, essentially, with a JWT. But what we really want to do is authorization. So the token here also tells the recipient what we have access to. And this is giving the This is giving now the attacker who is looking at the token more insight into what this token could be good for. Or Jason, any problems here with this?
Well, I see
Comments?
that you can take over the world. I see COVID vaccine formula. So I don't know, maybe there is some very sensitive information there.
And
But
that's sort of the next step then. So what we can do now is we can explore what other APIs are accessible using this token. And
yeah, I think some of these coincide with what we were talking about earlier.
Yeah.
So what you saw there, the ROM and the scope, basically what it tells you is that, hey, what this token allows you or entitles you to be able to perform with the application. And it is that, basically you hand this piece of information that is signed by the IDP so that nobody should be able to change it, right? So altering it, yeah, it's very difficult, if at all possible, right? But then it also potentially leak a lot of information to the user as to what the token allows you to do. Then you go after those services, right? As an attacker. Johannes, you're about to show it.
Yeah, let me just actually go back 1 second here. If you're looking at this, so we had like these different roles that we have access to. In the and we see that our token was sent, or our request went to this URL here. So next thing we can do is let's just go to the URL directly and see what we get back. Okay. Oop.
Okay, live demo, everyone. We're brave.
Yeah, I need. I of course need the token, so let me just.
Yeah, I think yeah.
Go this way. Yeah. So what we get here, it's a little bit hard to read because we're not looking at it in a browser, but we're getting like a little message here that tells us what the available operations are for this particular API. And this is not unusual. Yes, so this is an application that we created. Usually you don't get the COVID vaccine formula or the cat's plan to take over the world. Let me show you a real application, and let me go back to the map application again here for a second.
Yeah, let me talk while you're loading it up.
Yeah.
I just want to talk a little bit about the some of those job token. Well, there are a lot of questions about these token. When I talk to developers, the question always is like, hey, are these things actually secure? Yes, it can be secure. But only if you make it so, right? Some of the tips and tricks over there is that, if you're on the internet side, right? Like earlier in our diagram, on the left-hand side, you're dealing with the internet, the left-hand side of the API gateway. Then you would want to make sure that that job token, JWT token, is not like exposing all those like, hey, I can do this, I can do that, right? You would want that to be slimmed down and expose as little information as possible. But nonetheless, the job token is necessary to present itself, for some service to present itself to other services to say, hey, look here, the IDP said I can do this. So at some point you need to be able to present that job token with the IDP signature on it to acquire access. So what that means is that, here is a hint that will give you your API gateway in the modern architecture. That's actually a lot, right? Like earlier, Johannes was actually showing some of that. The Kong setup, the Kong is able to strip out stuff, as the data goes from the right-hand side, the inner side, to the outer side and strip out some of the content, within that token. So that's how some of the modern architecture keep itself safe. Johannes, I think you're ready. I'll let you take it back. Oh, you're on mute.
Yeah, just want to show you here quickly. This is, again, that mapping application. And here, for example, the requests go to this service here, Arc JS Online. Let me copy that. And go up here. You basically just experiment how much you have to strip off from the URL to sort of get again this basically manual and that tells you how to use this particular web service. And like I said, this is not unusual. This is actually a little bit sort of best practice. With SOAP and such, we often have more standardized versions of this, like whistles. Whistles never really sort of caught on with REST, but some form of documentation is what you typically find then with a REST service like this.
Yeah, it's more like the Swagger Open API. I think that's what you're referring to.
Yeah.
That sort of standard for REST, right? Like, and even then, is not. Well, there are semi-automatic way to generate that. It's not quite as automatic as for REST than in the old XML world.
Yeah. And now let me just change this here. Let's try the take over the world service.
We're evil. We're going to take over the world.
Yeah. I remember if there was a slash in the end or not. Well, we'll try it. We'll see what happens. Yeah. And now here we get now that plan to take over the world. And we get access not because of a failure to authenticate, because we did have a valid token that authenticated us for this particular service. But part of it was someone was too lazy, gave us a token that had really more privileges than we probably should have had, and sort of, again, relied on the good old security through obfuscation or obscurity, where in the old days we sort of had the hidden URL that you couldn't access unless you knew the URL, even though the URL did not really require any authentication. In the modern API world, well, we have the API endpoint that we have access to without really knowing that we have access to, because we don't really see that anywhere used in the application. Anything from you about this, Jason?
I think you cover it quite well.
Okay.
And I'm glad that it all works out. And
so far it works. Eh?
Yeah.
Now, with the authentication, there are a couple ways how these tokens can be authenticated. In our example here, everything went through Kong, went through the gateway. The gateway then is able to check whether or not we have access to a particular service. The problem here now can become, let me go back to our infrastructure. Actually, Jason, while I'm doing this, do you want to take that question?
I do. I'm just reading it over here. It's like, hey, Sans fanboy, yay. Thank you. Okay, the question really is about why would application development choose microservice over serverless? Maybe I'm wrong, but it seems attack service with a function as a service is limited. Okay. A couple of things here, right? Like, when you deal with a little bit of architecture context here, it's not mutually exclusive that you would do microservice and serverless. They could be all existing the same, right? A lot of times in modern day actual real world implementation, a lot of microservice actually tie in with container, just because it's easier to organize that way. Hey, one microservice, one type of container image. That's how people associate things. But there's nothing against, okay, so some of these microservices actually live on the function as a service, like your Lambda and the Azure functions. There's nothing wrong with doing that either. You could do both ways. And I think that may help you a little bit. So it's not like people are like, okay, microservice, and we won't go serverless. You can go microservice and serverless all at the same time. I hope that makes sense to you. Yep, we'll see.
Yeah, so really serverless is sort of a way to implement microservices too. So it's not that it's either or.
Absolutely.
Yeah. I just want to go back here to the architecture diagram. So the way we drew it here was that as a user, you're connecting to the gateway. The gateway will authenticate you and then forward your request to the appropriate service. Well, what prevents me from going to the service directly? In some cases, nothing other than, well, a firewall ruler, so that may or may not exist, or a configuration in your AWS setup or whatever you're using for a cloud that would restrict where you can access these services from. But as an attacker, if I'm able to find these services directly, I may be able to access those services directly, and with that bypass any kind of authentication. This is sort of, when we're talking about exposed S3 buckets and things like this, where maybe you have an application that requests data from the S3 bucket. The application does proper authentication, but if an attacker finds the bucket directly, then all of that authentication is going out of the window. And the location of these services can leak. It's not always that easy to find them. That depends again on where you have them located. But if you have your main service, your gateway in AWS, well, the web service, the backend is probably in AWS too. Or Jason, any hints on how to find these? Or
well, a couple of things I want to address here, like finding those exposed pass-based services are one thing, but then I think a lot of people assume that, oh yeah, I throw it onto the cloud platform, particularly with microservice. A lot of people are running the blue icon stuff on the cloud, which is good. Nothing against the cloud. Hey, if you know me, you know that I also teach the cloud courses as well. But the point about it is that it's one single line of code in today's world of IAC, right? Infrastructure as code. And then you expose your whatever service onto the outside. And you can't just say, okay, it's mine, right? I want to put a firewall. With cloud setup, there's not a whole lot of firewall, right? Everything is about configuration. You can configure these things called like private endpoint and so on in order to say, yep, hey, my corner of this pass-based service is not exposed to the world. You can do that. But if and only if you do that right, then you have the security. If not, good luck, right? Then you're exposed, as Johannes was saying. And as opposed to the enumeration of it, there are many different ways. We talk about like Swagger, we talk about like Open API. If somebody get their hands on those information about your schema, about where services are located, and so on, well, is a URL. People are just going to connect to it, right? So that's some of the very typical attack pattern that we've been seeing, for the last 18, 24 months. A lot of bad people around are pivoting over to these services in finding targets and attacking them. I think, we by the way, we do welcome any questions. There are some questions that are already flowing in. Definitely appreciate that. And now would be a good time if you want to ask us any questions. In these live format, hey, we will take questions, and it helps us drive where, the discussion is going.
So, Jason, one question here. In the architecture that we have on the screen right now with the API gateway authenticating all of these requests, doesn't that put a lot of strain on the IAM service. What if that service goes down?
Well, that's sort of the age-old single sign-on type of concern, right? I think there are a lot of discussion about these, and these days, a lot of organizations are moving towards ID as a service, and those provider generally helps you to distribute the load. And some of these are multi-cloud providers as well that actually, well, some of the big names there is like the Okta and the ForgeRock and those guys, they cascade themselves or they distribute themselves around like all three big cloud service providers to help you, with the availability. But then, hey, if you're running it on your on-prem solution, then, the onus is on you to make sure that that's available. And there are definitely a lot of, hey, the bad guys know that how important these things are. And they are definitely launching a lot of DDoS attacks and so on against these platforms. So just be aware of it. It's forever going to be like good against evil fight on an ongoing basis.
And another issue that sort of came up is these backend services. How do you restrict access to them? Is it just by IP address, or are there other ways to restrict access to them?
Yeah, I can take that one. Thanks, Johannes, for asking that. So the back-end services nowadays, right? If you're on your on-prem setup, more traditional, hey, network security, I call it castle and the moat sort of solution, then you're relying on your firewall. Hey, all these, sort of microservices, back-end stuff, hide behind the firewall, right? Like, hey, HO security model that is proven to work. When you are actually running, for example, Saki was asking the question about like, if you're running that model under serverless, right? Function as a service type of deal where you hand the source code over to AWS and they run it for you, then those things you need to look into, like the endpoint, private endpoint configuration. Basically, as I said earlier, that helps you to narrow it down so that you're saying, hey, this piece of code are only available, for example, to my VPC, only my internal virtual network, and nobody else can get access to it, even on the internet. And that's how you lock it down in lieu of a firewall, because firewall is an older lingo. In the cloud world, is getting less and less and less effective and relevant. So yeah, I think that's where people need to gravitate towards. The more cloud native land, the private endpoint, and those configurations are more important.
And then we have a nice final question here from Scott. We can close it with that. Classes we'll be teaching, Sec 522, that's a class Jason and I am teaching. I think next time I'm teaching it is in December. And Jason, what's the other class? You have another cloud class or manager class that you're teaching?
Yeah, it's a newer course that I wrote last year in 2019 or 2020, I think. It all mashed together, and it's about management 520. Is really about helping the management team to navigate around the whole, okay, what do I do to secure the cloud environment? Because these things all tie in together, and you need a lot of management support to drive it towards the right direction. So that's that. And hey, Sec 522 is what Johannes and I co-wrote, and a lot of material that we presented today are more relevant to that course.
Yeah. So thanks everybody. We are just out of time. I think we just timed it perfectly here, Jason. So thanks everybody for attending.
Yeah. Thank you so much.